Okay, so we're going to do some basic notes on scientific notation. You should have your handout. The first part of that handout, scientific notation, is used to express very small and very large or big measurements. So the purpose of scientific notation, a number that's extremely small or extremely large, is when we're going to be using scientific notation. Right beneath that, you will see a little diagram. This is how all scientific notation is written. It's a number. Let's call that a number in which only one digit is placed to the left of the decimal. So that's how scientific notation is set up. This first number, this n, is a number in which only one digit is placed to the left side of the decimal point. So what that looks like is 1.234. That would work. Only one of those numbers is on the left-hand side of that decimal point. So that would work for scientific notation. Another example that might work, 8.5432. That also has only one number left to it. So those are examples that, yes, they work for that n. On the bottom here, let me write a couple examples. No, these ones would not work. So if you have values of n that are like 0.0042 or 43, whatever, that does not work in scientific notation. You would need to rewrite that. Also something like 15.34. Notice how there's two numbers on the left-hand side of that decimal point. Since scientific notation states there only can be one digit placed to the left of the decimal point, 15.34 would not work for that n. This times 10 to the n, all that is an exponent of 10 by which the number is multiplied. So these are two examples right up here of numbers that work for our n, and this times 10 to the n just tells us, well, what is this number being multiplied by? Hopefully that'll make a little more sense in a little bit, but I want you to have both of these written down. You know what the n stands for. You also know what this power or this exponent piece stands for. This next part, these are some common exponents that you're going to see attached onto scientific notation. It's always times 10 to something. That's the way the rest of the world does it. They're pretty smart. Anything to the 0 power, always going to be 1. So we can go ahead and I'll copy that, put it on both sides of the chart right here. Anything to the first power is just itself. So that right there is 10. 10 to the first power is 10. 10 squared, all that is 10 times 10. 100. Should be okay with that. 10 cubed, same thing as 10 times 10 times 10, or 1000. Notice in this pattern, we just keep adding one more 0. So this one right here, 10,000, right here 100,000, you can finish off that chart. Over on the right hand side, we have these negative exponents. So instead of multiplying an additional 10, we're going to divide 10. So what 10 to the negative 1 power means is 0.1. 10 to the negative second power, oh, not 0.2, 0.01. We're dividing by 10 again. We have 10 to the negative third power, 0.001. If you can kind of see this pattern, as we divide by 10, we add one more 0 placeholder in here. So this is going to be 0.0001. 10 to the negative fifth power is going to be 0.00001. So you can finish off that chart. And if you go back a slide or look above really quick, the number which is multiplied by, so all these negative exponents, this is how we express really small numbers, by multiplying something by something really small. Positive exponents are how we identify a number that's extremely large. We're multiplying it by something like 1,000 or 10,000 or maybe a million, something like that. So scientific notation is just a really simple way to express numbers that are very small or very large. Last thing I want you to fill out for this video is how we know what the exponent is when we have positive exponents or really large numbers, and how we know what the exponents are when we have negative numbers or really small numbers. So positive numbers or positive exponents, each time the decimal place is moved one place to the left, the exponent is increased by 1. So an example of that, let's say you got 1275.45. Each time that we move this decimal point to the left, so 1, 2, 3 times, so that it's just 1.2, that's going to increase our exponent. So 1275.45, rewritten in scientific notation, would be 1.27545 times 10 to the 1, 2, 3, 10 to the third power. So that exponent just tells you how many times that decimal point has been moved. In this case, it's been moved 3 places to the left. So if you guessed negative exponents, you should be able to come up with this definition by yourself. But each time the decimal place is moved one place to the right, exponent is decreased, if I can spell, decreased by 1. So negative exponents, that means that we're expressing something really small. So 0.00045, that is a really small number. I want to express that in scientific notation. So let me count how many spaces I need to move in order to get my n value to have only one place next to that decimal point. So 1 spot, 2 spots, 3 spots, 4 spots, 5 spots. 5 spots is how many places I need to move that decimal point to the right. So my exponent on this is going to be 4.5 times 10 to the negative fifth power. So that would be how I write this small decimal right here in scientific notation. 4.5 times 10 to the negative fifth power. So go ahead and fill out the rest of the front side of that sheet of paper. Should have this. Right here, I want you to fill out this section. I give you the n value right here. All you need to figure out is the exponent that's on there, and then these next two, I want you to find out yourself what is that n value going to be, and also what is your power, your exponent going to be. I also want you to look at these real life situations down here. Speed of light in a vacuum. This is something scientists would use pretty frequently. Or the radius of an argon atom. If you notice, a lot of these things, maybe biology would use them. Definitely next year in chemistry, when you're talking about the weight of an atom, or the distance from one planet to another, from one galaxy to another. All those things are expressed in scientific notation because they're extremely huge numbers.